Finish up absolute value inequalities by talking about their special cases. Remember, I have two special cases, all real numbers. That's indicated with this symbol. That occurs whenever I have an inequality or equation that is true. And I also have the option to have no solution. And that occurs when my inequality or equation is false. When we talked about absolute value equations, so let's say the absolute value of -6, we talked about how the outcome of an absolute value can only be positive. For example, the absolute value of 2 is 2, then the absolute value of -2 is also a positive 2. So we don't get negatives when we take the absolute value of things. However, when we talk about absolute value inequalities, that's not necessarily the case. Let's look at a couple examples. So first off, let's talk about when we do have no solution. Notice that I have this absolute value is less than or equal to -12. Now, it certainly is not equal, but we want to pay attention to see if it is less than, if it can be less than -12. Well, think about all the results of an absolute value. The absolute value of 10 is positive 10. The absolute value of -10 is positive 10. Absolute value of -1,000 is a positive 1,000. Notice that each time I take an absolute value, the result is positive. So I have a positive answer. Now I'm going to compare that to -12. Is a positive answer or a positive number less than or equal to -12? No, it's not. This is false. Because if you think of the smallest positive number that you have, maybe 0.2, is that less than or equal to -12? No, it's not. No matter how small my positive answer, it's still going to be greater than -12. So my answer for this is no solution. On the other hand, let's look at this inequality. The same follows as with no solution. This is always going to be a positive answer. Remember, as small as 0.0001. And I'm comparing that to, in this case, -3. Is that greater than -3? Yes, it is. So this would be true, and my answer would be all real numbers. No matter what I plug into x, my answer is positive, and positives are always greater than negatives. So let's look at two more examples to make sure we have got the hang of determining the difference. So there's more things going on here, but I notice I have an absolute value is greater than a negative. So I'm going to ask myself, is that true? Absolute value is positive, is a positive. Pick any positive number. Is that greater than -12? Is 5 greater than -12? Yes, it is. So this is true. So all real numbers. Okay, positive again. Always positive. Hopefully you're getting the theme here. Is a positive answer less than or equal to -7? So pick any negative answer. If I had 3, is that less than or equal to -7? No, positives are always greater than, so this is false. So my result is no solution. All right, if you have any questions, please reach out to your teacher.